পুরসুরার হেভেলস ভিউ স্কুলে চলছে 3 দিনের বিজ্ঞান প্রদর্শনী। দেখতে থাকুন সরাসরি।
Welcome to our model exhibition. I am Michael Vinsha Ghosh.
I am Audrija Chakraborty.
I am Subhadeep Sharma.
I am MST Afrin Khatun.
Here, as you can see, our team has prepared a project called automatic street light. It is a small version that demonstrates in real life how a automatic street light functions.
What does it do? The model is designed to automatically switch the street light on whenever an object, such as a vehicle or a person, passes underneath it. Once the object moves away, the light automatically switches off. This simple mechanism helps in saving energy, since the light only glows when required, and it also reduces the need for any manual operation.
How does it work? We are using out here very basic yet very important electronic components, such as out here we are using a 4 BC557 and a BC547 transistor along with 1K and a 10K resistor. Also we are using out here an AR and an IR sensor. Out here we have 4 LED white lights. We also have a switch, a 9-volt battery, and few wire which connects the whole circuit. So how it actually works is that the IR sensor has a limited radar sensor. Once when an object interrupts the sensor, it interrupts the whole circuit, which causes the light to glow. Once the object moves out of the radar sensor, it again goes back off. That's all for our model work.
Good morning, sir. My name is Pursurah.
Good morning, sir. Myself, Atika Jasun.
Myself, Adityanan Bera. Myself, Akashdeep Kanar from class 10.
Today, I am going to demonstrate you of the false gold. Now, this is a test tube. I am taking a colorless solution. And now I am adding another colorless solution. As you can see, the color changes into bright yellow and there are some visible small particles. Now we are adding another colorless solution. Look, the color is vanished. So let's know the chemistry behind this reaction. The first solution taken was lead nitrate. The second solution was potassium iodide. And the third solution was hydrochloric acid. Thank you.
So sir, this is an orange color solution and this is a colorless solution. Now we are going to add this colorless solution to the orange solution. Let's see what happens. You can clearly see the color changes to light green. This is dark green and it is somehow the green, light green. So this is because in the second reaction we use H2SO4 as the catalyst. So this changes the color to dark green. And in the first reaction we did not use the H2SO4. So the color did not change to dark green. Instead it changes to light green. Thank you, sir.
I am Sayan Jana from class 12 science.
I am Kaushani Manna from class 11 science. Today we will demonstrate the chemical toothpaste experiment before you. Here you can see we have taken a violet color solution and this is a colorless solution. Now I will pour this colorless solution into this violet color solution. Let's see what happens. Here you can see a toothpaste is being squeezed out, but this is not the actual real toothpaste. Actually, the violet color solution was potassium permanganate with this soap added to it, and the colorless solution was hydrogen peroxide. When these two reacts with each other, oxygen gas is rapidly released, which gets trapped in the dish soap, and this forms a giant foamy column which looks like the real toothpaste. Thank
To show you the chemical traffic light experiment. So now we have taken a blue color solution, as you can see, and we will pour this in this conical flask. And after this, we have taken a colorless or a pale yellow kind of a solution in it. And after this, we'll just like to see what happens. So first of all, we will add a little bit of this yellow color solution in it, and if we mix, we can see that this is a green color solution. What happens? This has some oxidized this blue color, and some not oxidized, means the reduced this sugar solution. Now if we again add the whole thing in it, then it totally become yellow, and if we just swirl it a little bit, it becomes red. And after we keep it a little bit, after some time, it will again turn to yellow. As you can see, this is again becoming yellow, and the total solution becomes yellow. So now understand the chemistry behind it. This was indigo carmine, and this was a alkaline glucose solution. When these two are added, this indigo carmine was reduced, and after reduction, first of all, when the green color appeared, there was half reduced indigo carmine and half oxidized indigo carmine. Those two formed the green color, and after that the whole indigo carmine got reduced, and after that when we swirl it, the oxygen gas traps in it and forms an intermediate that gives us this red color, and after we keep it again in the still, it again turns into yellow.
My name is Pritam Mondal and I am from class 11 science. Today I will tell you some important facts of our digestive system. Do you anyone know what happens when we eat food? Let us explain. First of all, it's just a tray and some I have placed a biscuit. I am just placing it here. So let us see. I am placing it here and you can see the light of stomach. Actually, the food we eat gets into our stomach within very few minutes. Here it is written that
I am Debanjan Phorel from class 9, and here is my coordinator Nishan Samanto. Today we are going to present our demonstration, which is the igneous archive. Before you, you can see what seems to be a quiet and simple mountain, but this is not at all so. It has an immense amount of energy stored inside it. You can see some orange powder lying heaped on its top. Now see, as we provide the initial spark. Now watch on. You can see some dark green ash spilling out of the mountain. You can even compare it with some form of volcanic eruption. Now you may be wondering, how is this happening? So basically the orange powder that we provided at the beginning was our ammonium dichromate, which on heating decomposed into nitrogen gas, chromic oxide and our water vapor. The dark green ash that you are seeing is our chromic oxide, and the nitrogen gas is responsible for causing this form of eruption, which made it seem like a real volcano. Thank you, sir. Hope you enjoyed this.
We have rainbow flame experiment. As you can see that we have taken six color of white crystalline solid compound and blue colored compound. Now we all have seen yellow, oranges or blue colored flame, but today we'll show you rainbow of flames. Carry on. Then added to some methanol. and then set the fire. We can we can see the color of the copper sulfate gives pale blue green, and the lead nitrate gives blue white, and the boric acid gives pale green, and the strontium chloride gives crimson red, and the barium chloride gives yellow green, and the potassium chloride gives lilac, and the sodium chloride gives golden yellow. Now actually this experiment is known as flame test, where we can determine the metals present in the compound. Thus this is an amazing representation of how the similar looking compound given different color of flames. Thank you, sir.